Continuing on with our song playlist example, we now want to say, will the CLT for means even apply to a 25 song playlist? Why or why not? And what is the expected shape of this sampling distribution of song lengths? If you remember from earlier in the notes, in order for the CLT to apply, you need to take a sample at least of size 30. So we've only taken a sample of size 25 in this case. The answer here is no, because 25 is less than 30. So that's my why or why not. The answer is no, because the sample size is too small. The expected shape is that it will mimic the original population still. At least somewhat. Like, it might have changed a little bit, but it's going to at least somewhat. And if you remember the original entire population distribution in this case, where we were told that it is right skewed. So it's going to be at least somewhat right skewed still. If it's still right skewed, if the sampling distribution is right skewed, we certainly are not allowed to use a normal distribution to represent it and to do calculations with it. So we're just stopped in our tracks right here. We can't do any calculations on this as far as the central limit theorem is concerned anyway. So what about for a 100 song playlist? Would the CLT apply here? Yes, it will, because 100 is greater than or equal to 30. We've taken a large enough sample, so the sampling distribution will be at least approximately normal. It will be at least normal enough for us to feel comfortable using the normal calculator to calculate probabilities and feel like we're getting pretty accurate results there. And not only do we know that it's normal, we know specifically that it's normal with mean mu and standard error equal to this formula that we have. So it's normal with mean 243 and standard error equal to what we calculated up here, 9.3 seconds. So it's going to be, it's pretty wide. It's a pretty wide standard error, but we know that it should look something like that, centered at 243. And then of course we could count off our standard errors if we wanted to by going 9.3 seconds each time, but that's what it would look like. Okay. Since the central limit theorem does actually apply, now we are able to use Excel, it says then, to find in this 100 song playlist chosen from this population of 5,000 songs, find the probability that a randomly selected song in the playlist is less than 225 seconds long. If we think about what would that look like then, let's give ourselves a visual. We're in this, again, this normal population with our mean at normal distribution with mean 243, and we are down somewhere down here at 225 seconds, and we want to know the probability that a randomly chosen song out of these 100 would be less than that in length. So we want to find that area under the curve, or that probability. We've done this before, so we're using formulas, Excel commands that we've already learned. The new part now is determining, are we allowed to use this? Instead of being told up front, this is normal, and just knowing that you are allowed to use this, you have to determine for yourself, does this even apply? Did I take a large enough sample for myself to be able to use this. In this case, we can, because we already checked that the sample was large enough. So we're going to use the norm.dist Excel command here. Remember, in there we first put the value in question, so the 225 in this case. And then we have to put the mean and the standard deviation. So the mean is 243. And then for standard deviation, when we're talking samples, we use that standard error that we've calculated. So 9.3 in this case. And then we have to tell it true or false, whether we are counting everything below that value or not, or just that value. So we are counting everything below it. So it gets a value of true there. So I'm going to actually click over here into my Excel sheet. So probability of being less than 225, I'm going to type here, and then I'm going to, in the next cell, type in my formula here. So we want 225, 243, 9.3, and true. So it looks like we get 0.0264. I'm going to round that off to a 7 there. Watch your rounding directions on your own assignments. And then if I want to give that as a percentage, let's say, that'd be about 2.6%. So there's only about a 2.6% probability that if you pick then a random song out of your 100 song playlist, that it will be shorter than 225 seconds. Use Excel to find in this 100 song playlist, if you choose a song from it, the probability that a randomly selected song is more than 250 seconds long, which is 4 minutes and 10 seconds. So again, if we kind of visualize what we're looking for here, there's 243. 250 is over here somewhere, and we want the probability of being greater than that. In Excel, we can only find the less than probabilities, so we're going to have to find this probability over here, the less than, and subtract it from 1. So we need to do 1 minus the probability of actually being less than 250 seconds. So 1 minus, and then in order to calculate this part of it, we have to do equal norm.dist. I'll make this a bracket so it separates it. 250 in this case, everything else staying the same. With 243, 9.3, and true to figure out what this value should be. So let's see, let's calculate that. The probability of being less than 250 . So 250, 243, 9.3, and true. So that value is approximately, I'm just going to leave it as 0.774. So that's, again, that's this area over on the left. So we have to do 1 minus that to find the area on the right, the upper area that we actually want. And that would give us about 0.226 or 22.6%. And again, watch your own rounding rules on your homework and on your assignments. Use Excel to find in a 100 song playlist chosen from this population of 5,000 songs the probability of a randomly selected song being between 225 seconds and 250 seconds long. So a between, we've got 243 here, we've got 225 below, and 250 above, and we want to find this area between there. What's the probability of falling in there? Remember that in Excel, what we have to do is we have to first find the probability of being below the upper amount, so being below 250, and that tells us everything from here, from that 250 mark down. But we don't want all of that. So we have to subtract off. We don't want this lower area anymore. So we have to subtract off the probability of being below 225. Now, we can just steal some information that we've already found. We found up here the probability of being below 250 was approximately 0.774. I'm just going to steal that. And we found that the probability of being below 225, that was up in part H, that was about 0.026. Let's say I'm just deciding right now that I want to round to 2 decimal places. So if we do that, I haven't actually calculated this one yet. So what is 0.774 minus 0.026? Oh, I forgot that's not my calculator. I thought I had my calculator up and I thought I was typing in my calculator. Whoops, 0.774 minus 0.026. Oops. 0 doesn't like to work. Well, that's really not helpful, calculator. Real life problems happening. There we go. So about 0.784. I'm sorry, it's 0.748. Or 74.8%. Sorry about that hot mess of that last question. But just as a reminder, that's how you can find the below, above, and in between probabilities in a normal distribution. But that the real catch here with the central limit theorem is that we're doing this for sampling distributions now, and you have to meet that sample size criteria in order for this to work. Because again, none of these calculations work if you do not have a symmetric unimodal distribution. If it looks like something else, then all of this work just doesn't apply.